Hello, this is Shweta and my registration number is 15BEC0203. In this task 3 for digital logic design, I am going to implement the PCB layout for real-time applications. For the combinational circuit, I choose is 4-bit adder using 7483 IC. This is the circuit diagram for the 4-bit adder using the IC. I have successfully implemented the circuit in the multisim and got the results. For the circuit in the multisim, I have done the PCB layout in Altiboard. And this is the 3D view of the PCB design in Altiboard. The application for this IC I choose is 4-bit subtractor. This is the circuit diagram for 4-bit subtractor using 7483. This is the PCB layout in Altiboard and the 3D view. Coming to the FGPA, it stands for Field Programmable Gate Array. It's basically a programmable device with an internal array of logic blocks surrounded by a ring of programmable input or output blocks connected together via programmable interconnect. A typical FPGA contains a 64 to tens of thousands of logic blocks and an even greater number of flip-flops. Most of them do not provide 100% interconnect between logic blocks. The secret to density and performance in these devices lies in the logic contained. Some types of FGPA in Xilinx are XC2000, XC3000, 4000, etc. This is the typical picture of a Spartan FPGA from Xilinx. And different types of FGPAs available in Altera are Flex 8K, 10K, Apex 20K, etc. This is the picture of Statix 4 in Altera. Coming to the comparisons of FGPA from Xilinx and Altera, in build processor it needs one or more power PEC cores, whereas Altera offers ARM. The main differences in the design tools are at very low cost compared to ASIC tools. This is the FGPA family regarding Altera. And regarding Xilinx, this is the FGPA family. This is the revenue chart for some vendors of FPGA: Xilinx, Altera, Vantis, Latico, Astel, etc. Coming to the FPGA design, it has some advantages and own benefits. The advantages like faster time to time market, simpler design circuit, more predictable project cycle, field programmability, etc. And these include the ability to reprogram in the field to bugs and may include a shorter time to market and lower non-recurring engineering costs. The real-time applications of FPGAs are used to solve any problem which is computable, and is proven the fact that FPGA can be used to implement a soft microprocessor such as Xilinx Microblaze or Altera Neos 2. Specific applications include digital signal processing, software defined radio, ASIC prototyping, medical imaging, computer vision, etc. The security considerations are FPGAs have both advantages and disadvantages compared to ASICs or circuit microprocessors. These make malicious modifications during fabrication at lower risk. With its Statix 10 FPGAs and SoCs, Altera introduces a secure device manager and physically unclonable functions to provide high levels of protection against physical attacks. Some other applications are medical electronics, communications, etc. These are some other applications. Coming to the real-time applications of ASIC, there are some counters which can be done, like non-volatile, elapsed time, and event counter. Its features are real-time or event counter modes, non-volatile counter, 10 years non-volatile memory retention, etc. This is the diagram for that. Some others are micro power 555 programmable timer, its features, 10-bit 36-volt current DAC and its own features, 15-watt thermal controller which is used in precision clock generation, its own features, 8-bit microcontroller. Coming to the ASIC design, it has its advantages: full custom capability, lower circuit cost, smaller form factor, etc. The modern developments are a recent trend has been to take the coarse-grained architectural approach a step further by combining the logic blocks and interconnects of traditional FPGAs with embedded microprocessors. The high level of integration helps us to reduce power consumption and dissipation. An alternate approach to using hard macroprocessors is to make the use of soft processor cores. Companies like Microsoft have started to use FPGA to accelerate high performance, computationally intensive systems. By this task, I conclude that FPGAs and ASICs provide different values to designers. Information about that compares the two technologies. By coming to the advantages and functionalities, FGPAs are a bit better than ASICs. Altera and Xilinx are almost work with similar technology and have their own unique properties and features which are efficient in their own specific tasks. These are the references I did. By this task, I end my presentation. Thank you.